right, for the Unit 4 test review, we're going to do 3, 4, 6, and 7 on this video. All right, so number 3 says the equation that's given is modeling the height in feet reached by a coin. Okay, so we have an equation, we're flipping a coin, a referee is before a game. Use Desmos to answer all parts of the question. So it says, what is the initial height of the coin? So it says use Desmos, so let's graph this so that we can interpret the features of the graph here. So we'll start by typing in our function, negative 16. Remember, when you're using Desmos, you have to use x instead of t, plus 12x plus 4. All right, so here is our graph. I'm going to zoom in just a little bit to see it here. The initial height is where you start. Remember, the starting point is the y-intercept. Here the y-intercept is 4. And when I look at my equation, remember that starting point is also the constant on the end of your standard form. So this means that the coin is tossed from a height of 4 feet. Now, how high is the coin after half of a second? Well, seconds here is time, which is our x value. If I'm given a specific x value, I can go to the table, type that x value in, oops, I want 0.5, and it'll tell me that the height after half of a second is 6 feet high. All right, next they say, what's the maximum height that the coin reaches? Well, when I'm looking for the maximum, I'm going to click on the vertex here. The height is the y of this vertex, 6.25 feet. All right, and then at what time does the coin reach the ground? Well, that's the x-intercept. So you start at 4 feet, it goes up, it comes down and hits the ground after 1 second. And then finally, over what interval is the coin falling towards the ground? This one's a little bit more complicated. So actually, let me sketch a picture here for you really quick. Here's your graph. Okay, here's your axis. You start the coin here, and it goes up and comes back down. Well, we know it reaches the ground after 1 second, and its maximum value was at 0.375, comma 6.25. Now, where the coin is falling towards the ground is this interval, that part of the graph right there. And remember, an interval is always looking at the x values. So the x values here are 0.375 to 1. That's the time interval from 0.375 seconds to 1 second when the coin is falling towards the ground. And we typically write that as an inequality. All right, number 4. The per cost unit in dollars of producing a certain number of items is given by this equation. Algebraically, find the minimum cost and the minimum number of items that should be able to be produced to find this minimum. Now, I gave you a hint here. I suggest that you use the formula x equals the opposite of b over 2a. Now, what you have to know here is the x in this equation is being represented by n. N is the number of items. So first, in order to find the minimum cost, that's the c, that's like your y. In order to find the y, I have to find the x value of the vertex first, which I'm going to use this formula for. So really, I'm finding n equals the opposite of b over 2a. Well, b is negative 195, so the opposite of that is positive 195 over 2 times 0.125. Now, I would use Desmos to help me here. I would type into Desmos 195 divided by 2 times 0.125. And you get that the n, or the x of our coordinate, is 780. And that would be 780 items. Well, that's half of what we want. We know that it takes 780 items to produce the minimum cost, but now we need to actually find the cost of producing 780 items. So what you do is you take that x value and put it back in to the equation. So you'll have 0.0125 times 780 squared minus 195 times 780 plus 77,325. That's a lot there, but you are going to type that into Desmos and let Desmos do the arithmetic for you. So 0.125 times 780 squared minus 195 times 780 plus 77,325. Oops. There we go, 1,275. That would be your answer, and that's in dollars. If you wanted to, you could check by graphing this on Desmos, which I'll show you really quickly here. If I graphed this equation on Desmos, let me just take 1 second to type it in. The hardest part is that the window is really, really big. 77,000 is the y-intercept. So I'm going to make my y maximum 80,000. And the x's, I know my vertex is at 780, so I'm going to go 2,000 here. All right, and I can see, oh, I think I typed something wrong. 0.0125. Nope, it looks good. Okay, so let's see. Let's just zoom out for a second here. There we go. There's my vertex that I found, which I got it. I put an extra 0 in here. There we go. So let me zoom back in a little bit. When I look here, it's really zoomed out, but we found our minimum value here, 780, 1275, which is the x and the y value that we found algebraically. All right, next question. Number 6, we have 2 more. We can use the multiple choice, we're going to use Desmos. A cable hangs in a parabolic shape between 2 poles. So let's imagine these are like 2 telephone poles outside. So you have the poles, this would be the cable that's hanging. So it makes a parabola, and we are trying to find the, let's see, lowest height of the cable. So we're trying to find the minimum here. We're going to graph this equation in Desmos and find the lowest height, which is the y value. Height is always the y. So let's go first by typing that equation into Desmos. We'll probably have to adjust our window after the last one. So we'll have 0.001 x squared minus 0.124x plus 16. All right, and I'm going to adjust my window here really quick. Let's go. So bear with me for just a second. And all right, I can see my y-intercept, but my x's are not far enough out. So let's change that to, oh, that works. There we go. So I have my wire that's hanging down. It looks like the minimum is at 62, 12.1656, but I want the height, the lowest height, which is the y value, and that's 12.2, which does match option D. All right, finally, number 7, the height of an object can be modeled by the given equation, which is not an equivalent way of expressing the function. Well, it actually, there's a couple ways to do this. My suggestion would be just to multiply and distribute, all right? Because all these answers in the multiple choice look like they're just factored, and I want to get rid of the parentheses so that I can look similar to this equation. So if I distribute here, I'll get negative 16 t squared, and negative 16 times negative 3 is positive 48 t, which actually, oh no, it doesn't match what I started with. Yes, it does. All right, I think that's the answer actually. Whereas if I did B here, I'd have negative 16 t squared 4 times negative 12 is minus 48t. That's not the correct answer. Same thing over here. Negative 16t squared plus positive times positive is plus 48t. Oh, I think I read the question wrong. Which of the following is not an equivalent way? Oh, okay. Sorry about that, everyone. Which is not the same. So since the first one is equivalent, the second one is not equivalent. We're equivalent here. And then the last question would give me positive 48t minus 16t squared. Again, that's equivalent. So the only one that is not the same would be option B, which is the solution you want to choose. All right, we did not do every problem on here. I didn't do 1, 2, or 5. Go ahead and try those. Ask your teacher for help if you need it, and check the key that's posted on Canvas.